Okay, I think it started on YouTube. Let me see. Share. Okay, let me just paste it real quick. Um, I think it's. Or you can test that link in a second. Let me know.
Yo, JT, I'm be
What?
famous on this one.
What happened?
You're gonna be like the next flipping physics.
Mm-hmm.
Wait, it's on YouTube, but I have to go to check.
I posted. I think you. Well, you can join either. I believe. Let me find. Let me test it. What? One sec. Let me.
Yeah, I see it.
It works. Do you hear it though? Like, can you hear the audio?
I,
What?
that's,
I don't know. I can't hear what you're saying.
the audio is really bad.
It's really bad.
I think that's me. It's my mic.
It might. Well, your audio is bad. How is mine? Well, I can't understand you, bro. Like,
Okay, yeah, it works. It works.
okay, it's good.
It could be like a little louder, probably, but
My mic.
yeah, both. Like you're both in.
Okay. Well, let me see if I can
But
change.
other than that, like I can't hear it. Also, bro, why can't I leave?
I don't know. Oh, Heat said hi. I can actually see that for some reason, which is really
I was
interesting.
gonna able to see that.
Well, like I didn't expect that I would see it, you know.
Wait, I'm your top fan, bro.
Apparently,
I'm the only one. Okay, let me just go over this.
yeah, chill out. I wanted to set it up because there are other people that supposedly wanted to join.
I see one viewer.
Yeah, I don't. I know. Just chill out. Like, okay. I was just opening my. Let me. Okay. One sec. Uh, okay. Well, I don't know how to make it louder. So that's another thing for another day. Let me just put it like public real quick.
It's still hearable. Still hearable.
Okay, good. I'm not a tech whiz, you know.
Says president of Code Club Robotics.
Let me see if I can add multiple links.
You get
Probably.
Connor up in this chat, bro.
Can I get him out? Why would
No,
I get him
in.
out?
No, in.
Oh, sorry. Yes, I can. But he didn't click raise hand, but I can invite him.
Connor, raise your hand.
Okay, I invited him.
Good boy.
Um, how do I add? You can only add.
These two, bro, what is it?
Yeah, no, I clicked invite. He's got, okay. Well, he can try that.
Like that. The green names of some damn.
One sec. HC.
You could like, I know who gets up.
Okay, I made it public, theoretically. Okay, let me look at your question. Okay, where is it? You posted it on.
Should be a general. Tell me stream this questioning.
Yeah, bro, your mic
Like,
quality is so
I have more from repeat classroom. Yeah, let's see that. Just
uh-huh.
question 5 or no 4.
Okay, one sec.
No,
Okay, question 5. Okay.
4,
4, 4, 4.
5 was nothing.
Yeah, like as for that one, I don't really have a good answer for it. Like, I kind of just. So you're launching it at the center of mass, I believe, right? Let me see. Which following final? Would
Well, any
maximize the
every object was launched by its center of mass.
Yes, I guess. Well, it depends. You could launch it with a velocity from a different point.
But it rotates around its.
Yeah, so yeah, I guess if you pretend, yeah. Yeah, if you just pretend it's like the trajectory, it'll always be centered with the center mass at any given point. That's just when it would have the furthest distance. Like the right end to the left end.
Why
Like,
do we know that?
well, like if you just I feel like I don't know. What I would say is if you
You're
trace
not sharing your screen.
I know I'm not. Well, not yet, because I have to set it up. But I think in theory, like the center mass is always going to be centered in the middle of the trajectory. So like you just want the like to set it up such that the center mass is just farthest. I don't know. So let me see if I can screen share, if I have that capability. I really hope no one's listening because it would be. Okay, one sec. So like theoretically, you can see this, right? Can you see this? Sorensi.
Yes,
Okay, bro. Your mic is not great. Um,
I'm aware.
so like it always would like theoretically the trajectory would always launch from the center of mass. Um, so like it would end there as well. So it might look something like this. So this would maximize our distance. Like alternatively, if we rotated the block around, did the same thing and launched it from the center mass with the same trajectory. If we did it the opposite way, like like this, the ends of the block would be further or closer together. Like suppose those are the same trajectory, right?
So the D there technically would be the same.
Well, it's from the. Oh my God, what is math? No, because it's the distance is not the same because it says that they said the way they measured distance was from the right surface to the left surface, so it wouldn't be the same.
Oh, but the distance of the center of the mass is obviously.
Yeah, the distance for the center of mass is the same.
That's what I meant. Okay, but you don't like when you're measuring this distance
Generally, we're not
between
gonna have
two
to worry about
blocks. You're
center
not
mass.
really you measure from that center of
We'd
mass.
measure, yeah, but usually we assume it's like a uniform object, so the center mass would be the center of the object.
Right. Okay. Gotcha. This I still don't understand how.
Because look, okay, so no matter what, the distance the center mass travels is going to be the same no matter what. So
Mhm.
like we can rotate. Let me see if I can actually select this.
Oh, but in terms of the left and right, it has to be closer to the left, closer to the right, and closer to the left. Okay, gotcha.
So well, it's just saying the center mass is traveling the same distance no matter what, but you have to. It's just you want to maximize the distance between the right surface and the left surface.
No, but yeah, okay, gotcha.
So
That makes sense when
mhm,
you explain it that way.
yeah,
It's just like annoying
I know.
because it's not like a really intuitive.
Yeah,
You could like okay, 5 was not that bad. I think you just set the p coordinate equal to like the
this is
m1
AP
x1
Classroom.
stuff, right?
This is
That's it.
AP. I have to open it. It's AP Classroom.
I thought no, it's this. I thought you just had it.
Oh, I,
Oh,
I was
oh,
looking at
you
the one
looked at my
question.
screenshot.
Yeah, I don't know. I can.
Under face your screen.
Yeah, I can let you like add you to talk if you want.
I don't even know if he wants to talk. I just want to see how
Yeah,
he's feeling
I don't
about
even
this
know who's
exam.
listening, but I don't think it
Yo,
lets me.
comment on YouTube if you're listening.
I'm just streaming because I think someone asked me to do it last time, but I don't even know. I don't remember who wanted that, so I figured out how to make it work. Might as well do it.
Wait, someone's listening.
Oh, I know
They
that.
just commented.
Well, yeah, that's you. You You wanted to do 5?
Just as long as I know how to do it, I think 5 is 5. If I recall correctly. You just set that number of the point equal to the m1 x1 over m.
I gotta look at the question.
Yeah.
It's second law quiz.
No, Center Masters.
Isn't that the old one?
Yeah. It's still on it, no?
Probably. Platform with 3 rocks. Which coordinates? Yeah, you can set up like a 3 kg. So I would do like, let me see if this is working. No, it's not working. So I would set it up like for the x coordinate, right? The p for p is px is equal to, what is that, 7? Equals 7. So
No, I think I
yeah,
you set it equal to x1
3,
m
so it's like
whatever
3
stuff
kg.
for x and y, and then you solve for x.
A third rock. 3 kg times, what is it, 5
You solve.
meters? Yeah. You just, it's
Yeah, I got
plus,
that. That's easy.
yeah, -1 or -2, whatever, and divided
Yeah,
by the total
-2.
mass. I don't know.
Plus 4x and then divide by 8.
Yeah.
Okay. Can you do 6 though? Because like for something like that. Because like I'm still mad confused about that this center of mass like integration stuff.
Okay.
This one was I don't think that bad, but
no. What is the x position of the center mass? Okay. You can use your like the physics. Who's texting me? I think you can use the physics formulas. I don't know if that's.
wait, why would you use physics for it?
What?
What would you do? Can you just do like integration of xdm?
Well, you're integrating.
And then
Given this, so you're integrating with respects to length, right? With respects to x. So, well, look at the formula. This
I can't see it. It's not small.
look at this one here.
Uh-huh.
So it says well, lambda is equal to whatever. You just rearrange it, right? And I'm blind, but it's telling you to integrate lambda with respect to length, and that will give you mass as a function of length, I believe. Yeah. So just integrate with respect to x here. Wasn't that's just ax minus bx squared over 2? Then you
Well, how did you get to that, bro?
I just integrated lambda with respects to x.
Ax minus b. Oh yeah.
And then we plug in the values 2x.
Wait, it's b over 2x squared.
Yeah.
Oh, you said like
squared over 2. And then a 0.5 meter long rod.
But then you multiply it by x?
Well, yeah, but it's not just multiplying by x. You also have to divide by 2 for this, because it's the inverse power rule. You can't just multiply by x. That's how you do.
No. I mean, it's not just the integral. That's for the mass. But what about for?
You're integrating lambda with respects to x. For the mass, you just plug in these values at the end.
Right, but it's like x. It's like x dx, and dx is equal to lambda, right?
You plug
lambda at right now. Sorry, dm. It's x dm. dm is equal to lambda dx, and lambda you plug in, and then you integrate.
It's just lambda dx equals mass, and we're given that lambda is.
What about that x? What happens to the x and the x dm?
Just watch. Sorry, wrong thing. So we get ax minus bx squared over 2, and then you have to integrate that like from 0 to. Oh man, my screen share lost connection.
Wow.
Sorry.
The Jews are controlling you.
Did you really have to say that on my public? Like that's.
My bad. I forgot. I look, you forgot. That's my bad.
Yeah, it is.
I'm the one who got clipped, not you.
Meters. Okay. Oh, well, this is already integrated, so you gotta it's 0.5 meters
Mhm.
meters to 0 meters. So like you plug in this whatever it is, I don't know. Sorry, wrong thing again.
This is for the
It's
mass, right?
so yeah, you're solving for center mass though.
Like the summation of mass. No, that what you have right there is just the summation of mass.
Mm-hmm.
It's not
Yeah,
the
yeah.
top, not like the numerator.
Um, yeah, that's true. So 2 times, what is it, 0.5 minus 1
Shouldn't you start with
times
the numerator? I'm not gonna lie,
0.25
that's easy to
over 2
conceptualize.
equals 1 minus, what is that, an eighth? Yeah, 1/8 equals 7/8, right? And then you gotta do, so what is it, 7/8 divided by 2? I'm sorry. Is that, no, what am I saying?
Oh,
Divided by, what was it? Um, over the length is 0.5. I don't know. I haven't had the time to think. So yeah, you're integrating this to find mass, then you just gotta divide it by, I believe, what is it,
wait, what
integrating,
do you mean? You thought you divide by
okay,
mass?
so well, let me just go over the
Like,
equation again, because I kind of
yeah,
skipped a bunch of stuff.
hopefully the
So
equation.
it's, what you're, for center mass, the equation is, so R is a vector, RCM, it's just a vector, that just means center mass, equals, right, if I can write that, integral of
I'm not gonna lie, your note thing is no.
R, oh, you can't see it, that's right, R dm over dm, okay, and R is going to be x here, and dm is equal to the integral of, so if we rewrite this now, here,
You can just call it that. R is the same as that.
yeah, equals a minus bx, um, so if we integrate lambda with respects to x, right, that's going to give us, um, I believe, what is it, dm?
Ax minus b over 2 x squared.
I don't know, man, I'm too tired for this, but I'm
Right.
here.
Yes.
I'm
But
not
why don't
listening.
you just plug in lambda first for d? Like, why don't you get rid of dm first, then integrate?
What, 1 sec, equals dm
Lambda
over
equals dm over dv or dm over dx.
dl, or whatever. Yeah, so, you integrate with respect to L, which is x here, so dm equals ax minus bx squared over 2. So, what is that, dl? Or, whatever, a minus bx dx is really the, oh my god, I'm sorry.
Yep, that's what you said.
What you want to do for this is, the bottom is just going to be that, what we have there, right? A minus bx squared over 2 from 0 to 0.5. And the top is, so this is actually going to become x, that's x. So it's this times x integrated. X times a minus bx
A over 2x
dx.
squared minus
Because this is
b
saying,
over 3x cubed. Something like
dm
that.
equals a minus bx dx, right? So we're integrating r dm, and dm is this. So we put the dm here, and then r is actually x, but this is
But you
actually,
have to
well,
do the x.
well,
You have to like put it you have to multiply by x before you integrate.
yeah. So, well, you can, or you can use, you can do. There's other ways to do it that you
Okay,
should.
that's the best way to
So,
do it if
so
you're
you would get,
retarded.
yeah, sure. So you would get ax squared, x squared over 2 minus, what is that? Bx cubed over 3. You integrate from 0 to 0.5 over the same thing, a minus bx squared over 2, 0 to 0.5. We can do this, I guess. What is this? So a is 2 a meter, and b is 1 kg per meter squared. Okay, we'll solve this, I guess, right? So, 2x squared over 2 minus x cubed over 3, and then we just plug in, only have to do x equals 0.5, plug in there, over, what is that, 2 minus x squared over 2, x equals 0.5. Actually, no, we can't just do that there. We have to subtract a. That was a mistake. So 0 to 0.5. So if we simplify this, what is this? I don't want to do this, but so that's messed that up. X squared. So 1/4 minus, what is that? An eighth times a third, 24th. I don't know that. Over 2 minus 1/8 minus 2. So this doesn't look right to me, but that's okay. We'll just keep going with it. So 6/24 is probably not right.
So 0.24, 5 over 24.
This doesn't make any sense, but we'll stick with it.
0.2. It's like a little off.
Yeah. Yeah. It's 5. What is this? 5/3.
It's some mistake. For sure.
What is 5/3?
Yeah,
Yeah, so I completely messed that up. But the concept is there of what you're supposed to do. And I'm sorry for anyone I'm confusing. Sorry, I can't hear you. Oh, I didn't notice the people here that I'm possibly misleading. Oh yeah, let you talk. Here you go. Yeah. I did mess up the integration, but like.
Yes. Good morning, people.
Hello.
I was just studying for like an hour and a half with Rayhan trying to figure out how to do one question.
I messed this up.
The one on the slideshow, the one that we did in class, or not an hour. We spent like a good 20, 30 minutes just trying to figure out how to do the one question on the slideshow, the one with the lambda knot.
Right.
And all that.
Oh,
Are you serious?
It's kind of like this, I believe, right?
It's like the same thing, except the function is different.
Oh, this question is basically the exact one that's on the problem set.
Oh wait,
Oh wait,
it's the problem set's not different.
No, it's not.
No. GT, do you, like, let's just say for one of these questions, do you have to use 1 over m, or can you just use RDM over DM?
Well, no, 1
That's
over
the same
m.
thing.
1 over m is always just like, it's just dm.
Yeah, 1 over d integral of dm. Yeah. But
M
I'm
is
just
just
saying,
a variable
like,
that represents mass.
do you have to pull that out, or can you just keep integral
No,
of
you don't
dm on
have
the
to
bottom?
pull it out. I didn't, but it does sometimes help. That's just saying, like, if you solve the bottom first, then you can pull it out because it's a constant. Then you could do the top first, then pull out the bottom. It's really,
But that only works if it's a constant, though, right?
well, the mass is always gonna be a constant. DM, the whole purpose is that you're finding the mass, like the total mass of an.
Oh, sorry. Yeah, but the instantaneous points of mass are not.
But because you're integrating, it's no longer dm. It's just m, like big M, which represents the total mass. So you can pull it out at the end, or you don't have to. It's a choice. I messed this one up.
Not my tutor, Ralph. Not my tutor.
Bro,
Yeah.
you know what's crazy? How I get how to do this stuff, but I don't remember how to do this stuff from last year.
Are you serious, Ralph?
You took physics last year?
Yes. Wait, Zach, did you start
Do
the
question
problem
5 with Nico, because that will show him how to do it last year.
This is just a center mass summation.
Yeah, that's probably stuff that we did last year.
Okay.
No, you idiot. I meant the free body diagrams, that stuff.
Oh, my bad. I thought you meant the center of mass from last year.
No. That's easy.
That's why I was like, what are you talking about? Okay, do the other AP question.
Which one?
Wait.
The new one.
One sec.
Spencer, his work was wrong for question 6, so I would not recommend you.
Yeah.
You should.
I'm gonna redo it real quick. Possibly correct, possibly not.
Just
Did you
watch
do the
that
problem
video from that guy on YouTube.
Did anybody do the problem set yet?
No,
Or
No,
start
it's
it?
not due till like the 14th.
I know, but I started it because there's good practice problems. I have no idea how to do one of them.
So
Pissing me off.
what is this? I don't want to really do this, but x squared. I'll just
Here, I'll give you a better question to do.
1 sec. I just want to finish this real quick, just to make sure I did it correct.
Alright.
Over. Let's see. So 0.25 minus 1.125 over 3 over 1 minus 0.125 minus that's where I messed up before. 0. I think this will give us the right answer if I unplug it anyway.
answer should be 0.2.
Let me check. 0.25 minus over 3 1 minus 0.125. It's what was the answer?
0.24.
Yeah, so that checks out.
Yo, I have a good feeling Max does not know how to unmute or like actually speak, because otherwise
Well,
he'd be
he's
yapping
done
his
it
ass off.
before.
I know, but like if he's in the voice chat with like permission to speak and he's not speaking, something's wrong, bro.
Oh, his mic broke.
I
Spencer,
just have a
Yes,
heart attack.
thank God.
Spencer,
Bro.
did my work make sense? You want me to?
Let Jack speak.
Oh, he's not even here. He has to request it. I mean, I can
He's
invite.
7 in general.
There he is.
What are you getting in the test?
Oh my god, hello.
Hi.
Jump screen.
Yes. Max's
Oh.
mic is broken, so I don't know. He's been trying to talk, but he can't.
I think that's
Yo,
a
GT.
that's a blessing, bro. In disguise.
That one, what do you want about?
Alright,
The
bro.
acceleration, I guess.
Bro.
Okay, so the
Jack, mute yourself.
the force parallel.
Oh wait, my bad.
Okay, so
Is that Max?
Yo,
Yeah.
yeah, it's Max and Spencer. I can hear Spencer's voice.
Yeah.
JT.
On Jack's.
Yeah, on Jack's phone. Or whatever.
What were you saying, Nico?
Can you go to your like blank doc real quick? Because I remember the question. I just don't know how to do it. So basically, it's 3 different scenarios. One is it's one block being pulled to the left by a force, right? And then the next scenario is 2 blocks being pulled by that same force.
Were they next to each other?
With no, they're connected by a string.
Mm-hmm.
Like that, and then also being pulled the same direction. And then the next scenario is the exact same thing, all connected with strings, with 3 blocks. And then it asks you to rank the tensions in the strings.
Mm-hmm. Okay, sure. So
And then the first one is A, and then it goes the 1, 2 is B, C, and then it goes and blah
sorry.
blah, so on and so forth.
So you want to rank the tension in these strings?
That's what it asks
Okay.
for, yeah, I'm pretty sure.
Are they all have the same mass?
Yeah, everything
So
is same mass.
F1 equals M over A, right? So F1 I'll separate each situation. S1.
Yeah.
So F1 over the total M we're just gonna arbitrary value equals A. S2 F1 over 2M equals A.
Mhm.
S3 F1 over 3M equals A. Alright, so we're ranking the tension in like which strings in particular? Is it like
Yeah, I think. I don't know. It like
Bro,
labels the block.
that wasn't a
I
yes
said
or
which
no.
strings are we ranking the tension in?
Wait. I'm trying to think how the question was set up. I think it like I know you didn't ask, but like it like labeled all the blocks, but then it asked for the tension in the strings and didn't label the strings.
Oh, between each of these strings, like so this is A, B, and C.
I don't think it did it like that. I think it like labeled the actual blocks themselves, but then asks for the strings tension. Whatever, that doesn't make sense. Anyways, go on.
Well,
Sorry.
I don't if I don't know the question, how am I supposed to give an answer? I
Um,
can explain. So these three strings, we can do the tension for each of them. Um,
okay.
so let's see. So this, right? This block has a mass of m and
Here, wait, you know what?
x.
I'm gonna grab my problem set.
Yeah, why
See
don't you
if I
find it?
1 second.
Wasting my
That
time.
would. Well, I think it's actually a good question if he finds the question.
JT, would you want an ounce of copper for your services?
I'm okay.
Sure.
Yeah.
It's like $5.
All right. It labels each
Are you able to
block
send it or
and it
no?
asks, do I have what?
Are you able to send a screenshot in the chat?
Oh yeah. Here. 1 second.
Yeah, you can put in general if you.
Yeah, that's what I'm doing. It's loading.
Okay,
There you go.
1 sec. Okay, let me open it. Well, that's sideways, but that's fine. Boxes are pulled by ropes along frictionless surfaces accelerating toward. All the boxes are identical in the acceleration. Oh, the accelerations are the same. Okay, so here that makes more sense. Rank the tensions in the ropes. Is the pulling force being acted by a string? Is it like a rope that's pulling? Okay, yeah. Boxes are pulled by ropes. So these are also. Okay, I see what's happening. Okay. I want to force. Okay. What I'm gonna do the setup. I'm gonna redraw it, I guess. So the acceleration for all of them is the same, which is useful information. I'm just redrawing it. Then we'll go B. C. You're basically just using Newton's third law over and over
Yeah.
again to see like which has the greatest force in terms of their DEF. Okay, so
Yeah, but I'm like confused because don't like the forces cancel out from
okay,
the strings?
so well, the force of tension on the like, I see what you're saying. These like if we drew the force of tension, right, one is going this way and one is going this way,
Mm-hmm.
those would cancel
Mm-hmm.
out. But if we just look at E as a system, it's
Mm-hmm.
this rope is gonna have a different tension than this one, so it wouldn't cancel out. Here and here they'd
Mm-hmm.
cancel out, but not here and here. So, alright, so let's see.
Oh. Okay.
So this
Okay.
is F is equal to, they all have a mass of M, by the way, right?
Mm-hmm.
So this is F is equal to MA. Now this one, this is pulling both of these
Mm-hmm.
at an acceleration of A. So if we pretended, right, if we just pretended these became a giant rectangle, like a single block, and we called it block BC, we pretended that was one block, it would have a mass of 2M, right?
Yeah.
So we can treat it like a system, like a block, almost like a single block, isolated. It has a mass of 2M and acceleration of A. So if we look at this single rope, the force it's going to be exerting, the tension is 2MA. So like that's a way to approach it. We can look at them separately. There's multiple ways to do it, but I think it's easiest. So this is going to be 2MA. And then this one is going to be pulling what? It's a single block, mass M. That's the only force acting on it. Since we know the acceleration, the mass is M here and the acceleration is A, there's only one force on block C, right? If we drew block C,
Yeah.
all it is FT, force of tension. Okay. Then we're gonna have kind of the same premise here. Hopefully I got this right. Like that would. It's easy to make mistakes on these. So if we treated these like a single block, 2MA. Do you have the correct answer?
No.
Okay. Anyway, if someone thinks I'm wrong, please just tell me. So greatest to least. The way Ms. Donahue would format these, that you can say they're equal. So the greatest is the 3MA, right? So that's D.
Wait,
And
so
we have D,
why
then we have
why is
2MA.
that? Why is it 3 MA on D?
Because
Is it because it's
okay,
pulling all
this
both
is a
We
all the
real-
went like
blocks?
right to left.
if we pretended that it was just pulling a single block, and that block had a mass of 3m, and we know that
Mhm.
everything's pulled with everything has an acceleration of a. So if this was a single block with mass 3m, and then acceleration's a, and that's the only force on the block, it's just 3m times a. Force equals mass times acceleration. Like if this was a single rectangle, there was no ropes inside of it, no separate blocks, just one block with mass 3m, and acceleration of a. Like the acceleration of the big block would be the same as all the small ones. So it's 3ma. So E is going to be equal to E. This is E here. Is
Equals
equal
M2.
to
Yeah.
B. And then we have, what is it? F equals C equals A. I
A
believe
is the I know.
That's the
Yeah.
correct.
Okay, I got it. All right, it's not that bad.
Oh.
Oh, you want to know another way to look at this? Check this out, right? So what's the acceleration of block B?
A is it not?
Okay. And the
A?
mass is M. So if we draw block B, it actually has two forces of tension. B, so FT1, and then FT2. And we know M equals M. That's a stupid way to write it. A equals A. So Fnet, right? Fnet equals
Yeah.
equals FT1 minus FT2 because they're in opposite directions, and we know it's equal to this mass times the acceleration is ma. So FT1 is 2ma, so equals 2ma minus ma. This is ma. So it does equal ma. That's just another way to show it. So this string is pulling 2ma forward, 2ma backwards. That subtracts, it's pulling 2ma forward is the net force, and that gives us that this block is accelerating at a meters per second squared to the left.
Right, got it. All right.
Does that kind of make sense? Like if we drew the free body, that's how we would represent it. Two different tension forces.
Yeah.
The F net's MA. That still works. Okay. Yeah. So.
More EP classroom.
More EP class.
Like from the current like review stuff.
The most recent assignment.
Yeah.
Alright. You want the second law quiz?
Was there one on the other stuff?
Is there one on the what?
Like I know he posted other stuff, but I did not
Third
do
law quiz, first law quiz?
I didn't do those. Were we supposed to do those?
No, it's practice, optional practice.
Oh shit, I should have done that.
Yeah.
Did anyone do those?
I don't know. Well, they can't talk, but also I don't know that they did.
We do like I guess do the one that it's
Which one?
I'm looking for which one.
You said the first law quiz?
I think he did second.
We already did second law. Oh, you want to look at the one that we did already?
No, because we did it next season.
Oh, well, your mic is
Wait,
bad,
there's
so
a
I can't.
quiz. There's a quiz for every single law.
Bro, I did not realize that.
No, he posted these as practice
Alright, what's the hardest conceptually to understand?
of everything we've been
The
doing.
second.
I would say that's probably center of mass, understanding the
Okay, but we did
Mm-hmm.
maybe do like some of those like block systems and like
Are there any
those would be
actually yeah. All right, yeah, fair.
like maybe like question 2 on there instead of log, which I didn't even look at it.
Ooh.
So it'd be easy.
Let's do this. Let's do this. block is at rest on the desk's horizontal surface, the student correctly identifies the force as the force of Earth on the block and the force of the desk on the block. Book is then placed between the block and the desk. Which object exerts forces of equal magnitude on the block after the book has been equal on the block? Okay, sure. So, alright, that's going to be the Earth and the book. I will explain this setup. You like 2 questions from each. Alright. So, we have a block on a, what was it, a desk, right? Yeah, on a desk. Right. And so, what's keeping this block from clipping through the desk is the normal force, Fn. Let's not make
Yep.
that racist. And Fn is going to be equal to Fg, gravity.
Oh, how would it be racist?
So that means
Yeah.
so
that's
that
what I
means
was about
F
to
net
say.
equals 0, right? F net equals 0. So no
Mhm.
acceleration, A equals 0, V equals 0. So
Why
that's
did it say it's at rest?
So now
Okay.
if we put a book, pretend that's a book, like a, I don't know, like a book on the block, right? What's keeping it from clipping through the book now?
The
Fn.
normal force.
And the Fn is
Normal
coming from the
force.
book actually, because the block is pushing down with Fg on the book. The book is returning that. That's Newton's third law. So it's gonna be
Yes.
but the Fg is technically coming from the Earth. It's the force of the Earth on the block, and then the Fn is the force of the book on the block. So those two are going to be of equal magnitude. So the Earth and the book are exerting forces of equal magnitude, opposite directions but equal magnitude.
Wait, what? Repeat that. What? That last part.
So both the Earth and the book are exerting forces in opposite directions but equal magnitude on the block.
What's the Earth doing to the block?
Gravity.
Gravity.
But
And
is the normal force
is from
all
the
from
book.
the book, or is it
It's
like
all from the book.
for components of it?
It's all from the book. It's from the book pushing against the block. And yeah, I can look. Where'd you?
Wait, so you said like what's keeping it from going through? What about like quantum tunneling?
What about quantum
What
tunneling?
relevance
I don't know,
what
Zach.
relevance does
Maybe
that
go.
No, because like if I slam my hand through,
Hey,
like
so
you
Zach,
said, normal force should act on. Why does it go through? 1 in a trillion times.
I don't know. Maybe Zach, you should throw a ball at a wall 1,000,000,000 times your entire life and see if if the quantum tunnel works.
Okay, bro. Get it.
Just do like you know how Forrest Gump never stopped running? Just do that throwing a ball at a wall. And then
these
you'll
are
eventually
actually pretty
You know how
solid
like
conceptual.
Serbia is a better country than Croatia?
These are pretty.
What?
Okay, can we stop with that?
Well, then.
These are actually pretty solid, like questions, like conceptually speaking. Like they're not math; they're all conceptual.
You think he's gonna? I think he's gonna put math
Oh,
on
I
it. I mean,
forgot to
he's making
say.
the question.
Wait, let me put
himself.
something in the group chat that I forgot. That's no one's gonna want to hear, but yeah.
What?
Oh, where's the group chat? Let me find it.
Oh, didn't I heard something about this?
Are you sure? Where is it?
Maybe
Oh, yeah,
he only oh, I don't know. Maybe actually, I don't know.
Wait,
Okay, there we go. I forgot to say that earlier, but I don't know, Gian.
What?
Yeah.
No, bro. No. No. Oh my God, I know what he's gonna do. I have a feeling.
what?
I have a feeling he's gonna. So, with the density question, or like with one of the center of mass questions using the calculus, he's gonna make the upper bound like one number, and he's not gonna make the lower bound 0. He's gonna make it some like actual number. So we have to actually do everything out.
That's not annoying, bro. That's literally a simple
That's
plug-in
very
that you
annoying.
subtract. Bro.
What?
Can you repeat that, Nico?
What are you talking about?
He thinks.
No. You know how the question gets 10 times more annoying when you're doing like a center of mass question and then you actually have a lower bound instead of 0.
Well, 0 does actually can affect the lower bound
I
depending
don't.
on the function.
It could, but it usually doesn't.
It's not that bad if there is a lower bound.
Or he might put like a triangle on there and tell us.
No, he
it's
said he
center
can't.
mass.
He said he can't.
Why?
Oh,
He won't.
all
So,
right, never mind.
when we did the lab, he said this won't be on the test.
Okay.
Very good.
But that's simple, bro.
There's a question. Now we're all trying to predict if it's the free response question, he's gonna get slimed.
What's an area density question mean?
It's just saying a 2D density question.
I don't
Yeah.
understand what that means.
It's the density
It's the
of a 2D
same
object.
thing, just with this
Oh.
with what's that? Wait, what's that letter called, JT? The one they
What?
use for
M?
3D?
Sigma, you use sigma for 2D, lambda for 1D, and rho
No,
for 3D.
is that what sigma is? The one with the little circle, like the circle.
Wait, can you do one of those? Because I don't know what that means.
That's
Oh.
lambda.
1D. So this is sigma, right?
Yeah, sigma.
Nico,
And
you're
then-
actually so immature, bro.
No, he's not making not too.
No, I just heard him chuckle, bro. I
I know.
literally heard him chuckle.
No, I didn't, Zach. You're schizophrenic.
Bro,
Do you want me to do one of the questions? Do you have? I was
Do
doing these are actually.
do like a one of the questions with sigma, because like there's one with rho and then there's one with lambda in
Do
the
you know
notes.
where I can find that?
I don't know, because that's the only one that's not in the notes. Honestly, should I just ask ChatGPT? Because well, I mean,
You
there
can
might be
ask
one of
it
the
to try
AP
and make one.
platform.
Or we can make now you know what we'll do? I have a better idea. We're gonna do you wanna do a sigma one or a lambda one?
No, we
Sigma.
did plenty of lambdas, bro.
Sigma one?
Yes.
Okay. Let me think about how this should be done. Sigma equal, I gotta think about this. So we have one dimension. Could do something like. It's hard to make one from scratch. Like just thinking of it.
Just look one up.
Sure. Let me ask. Let's see if ChatGPT can give me. Okay. Oh my god, that's a horrible question. Are we serious, bro? Oh my god. Alright, give me a sec. Okay, now we have something. So, sigma of x equals 3 plus 2x kg per meters squared. What the heck is this? A
What?
thin. I feel like this is a horrible question.
Just what?
Yo, matter of fact, why don't we just all go to bed and accept the fact that we're cooked?
Bro, I'm actually so cooked.
We are all cooked.
Yo, Nico,
Bro,
Nico,
I
can you just
barely know
fail so the curve is good, bro?
I barely know how to
But
draw
there is no
two-body
curve.
diagrams, bro.
There's no curve. Bro. Nah, man. It's over for us.
Okay, so this is our function if we want to find, and it gives us that x is 0 is less than x is less than 2 meters. I don't know how this is helpful. 0 is less than y less than 1 meter. Okay, and t.
Yo, I'm not gonna lie, I have no idea what we're doing on this on the
We're
street.
just finding density.
Mass over volume.
So let's see. So we know that density or whatever sigma is wait, what am I trying to find? I don't know. ChatGPT is not good at making these. That's part of the issue. I don't like this. So dA
It's not giving us this shit, bro. It's giving us lambda.
Equals 1 meter. Yeah, I don't
He shouldn't give us one because there's literally nothing about that on the notes.
well,
mean,
no,
there is, but
but I don't.
we didn't do like a
ChatGPT's not making
question.
good questions. If someone has like a better
No,
practice
like
one,
he won't give us this.
I
I don't-
wouldn't say that.
Unless,
Bro.
maybe that's the evil question. Honestly,
He didn't make the test at the point, at least by our period, first, second period. So, JT, what did he exactly tell you?
What he said there was a question on it that no one's gonna like him for.
Okay, but first, like when I asked him second period, he said he hadn't yet made the test.
Yeah, but I think he figured out what he wanted to put or something.
So if he knows we're not gonna like it, why did he just not put it?
Because
bro.
it's
I thought he was
physics.
chill, bro. I thought he was chill.
It's physics, dude. There's.
I don't
you can
care.
be
I'll take
chill.
a 2 on the AP and do well in the class for now. Like dead ass. Nico, I know you agree with me on it.
Facts.
So,
I think
so,
what all of us need is a good night of sleep, and then
bro, on God, I'm just gonna go to sleep and just pray, bro.
Oh,
Can we
I see.
can we all diversify like the gods that we pray to, so we each get better luck on the test tomorrow?
Wow.
So Nico, you're probably Catholic, right?
He is. Not that that's
So-
relevant.
JT, wait, oh shit, JT, can you just switch up for a day?
I'll pass.
Which no, we
We
got
can't
Hadid.
double
Hadid,
up, bro.
we have Hadid.
We got
We got
Hadid
Hadid,
for
okay. We got who's okay, we're good. Connor's looking non-denominational, so that's pretty.
So then,
Okay, you
he,
can give me a
yo,
practice problem.
he
But I think we've done this
he
one already. Yeah,
prays
we
to
have.
like
Yeah, Jack even being an atheist is messing us up.
Graydon is not helping.
Graydon's just guy.
Graydon's just Graydon's Graydon.
Then we'll do lambda of x
Yo,
equals.
can we just focus on the shit from last year? Because like I've done so many density
Yeah.
problems.
I think that's a great idea,
Like
Zach.
I'm just gonna get that wrong and just hope that he makes it weighted less. That's this really hurts me. Like I don't actually know the stuff from last year.
Yo, bro. Actually, I know how to do this question.
You do.
Yeah. Is this the one from the slideshow?
I'm not gonna lie, Wong also lied to me. He told me that he would make it so we could see the answer right away.
My ass.
Over dl dx. So dm equals lambda 0 x plus x squared over 2l. Well, that's dx rather. I don't want to do that yet. 1 plus x over l dx, which has to be integrated. So equals. Let's see. So we can pull out this actually. So dm is equal to that. So we put the dm in over. So dm. All this stuff goes in over here. So now we're integrating with respect to a variable we actually know. Let me pull this out. 0 of x plus x squared over l dx. From 0 to l is where we're integrating over this, and then we're just integrating dm on the bottom. 1 plus x over l dx, 0 to l. So that's going to give us, those two cancel out, obviously. X squared over 2 plus x cubed over 3l from 0 to l over x plus x squared over 2l from 0 to l. And this is going to be some big number. L squared over 2 plus L squared over 3 over the units match, which is always good. You want unit matching to happen. That's a very good strategy always for physics, to check unit matching. Right? We have meters. L is meters squared over meters. So That's always a really good indicator you did something right. Meters squared over meters equals meters.
What if you're like me and Nico and you don't even get to them?
Well,
No,
then
no,
you
no.
do
I
some
I can
guess.
get here. I can
You
get
do
here.
some
This is not hard.
guesswork, right? And you can get some partial credit. So that's
Zach,
obvious.
who is me
That's gonna
and
be
Nico?
5/6 L squared, I believe, right? Yeah, over 3/2 L. L. So 2/3. What is that? 10 over. What is that? I don't know. 18L. Is that right?
I'm not gonna lie. What is your denominator? Is that K or an L?
That's an L. Why
Oh,
would
but you crossed it out.
Oh
My
yeah, it
bad.
was crossed out. Sorry.
So it's 10L over 18, which is 5L over 9. 5,
Yeah,
yeah, I
that's
remember
right.
this problem. It was 5 9s too.
Cool.
Yes,
5/9
it's
L.
5/9 L.
Yeah, make sure you don't just put 5/9.
L, not bad.
Gian, yeah, we just did that. So lambda, okay, so the definition of lambda, right, on a macro level. So we look at macro versus micro, right? Lambda is a density in one dimension, which is equal to mass over length. But on a micro level, like atomic or whatever, it's equals dm over dl, right? So
dm over
what this
dx.
means is, let's say we have a function for lambda, like lambda of x equals x, right? We can, if we rearrange this, rearranging this gives us lambda dl equals dm, right? So we could actually solve for this, but then that would become, if we were to, like, this means integrate with respects to L, or we could make dl could be dx, but, so if we actually were to integrate this, right, lambda of x is equal to x, dx equals, this would actually, the d's kind of disappear even though they're not fractions. This is saying like times a little bit of L equals a very small change, or a little times a little change in length equals a little change in mass. So it wouldn't be fair to say lambda times a little change in length is equal to mass. We can't do that, but we can say if we integrate it, then we'll actually say it's equal to mass at the end. So it's equal to m. And we said lambda x
Like
equals
Nico
x.
got mad experience with that, bro.
So this becomes x
What?
squared over 2 plus c. We need a plus c here, equals m. If we were to like, if we knew like the length of it, then we would get rid of the plus c, because
Oh wait, the C. Okay, C is
Yeah,
if it's
lambda.
not like a fixed thing.
so yeah. Is there anything harder than
It's
this?
not like from L to
Um,
0.
You could have like another proof or something. I don't know.
honestly,
You could theoretically
I-
give us a proof
I'm already
What do you mean?
done. I'm going to
for
bed.
3D.
But don't even bother. He's not doing it.
Like rho equals a, or what is it? M over ABT. See?
Wait,
Is
so
there
the
anything-
difference between like the rows and the sigma
Rho is
is
3D, sigma is 2D, lambda is 1D.
so rho will just have like an extra
It
multiple.
really depends on what the function is. No way he gives something harder than what.
It would just be like
Gian,
times
he's gonna
like.
give one question that you'll hate.
But rho would just be the same as lambda, but like times like a thickness of some sort.
It could, a rho is, it's ABT.
It's like the same thing. Though. It'd be like, yeah, instead of the AB, it's just
He
ABT.
explained this in the notes, I think, right?
Yeah. I just don't understand what the sigma should. I'm not. More honestly, I'm worried about those multiple choice because it's not curved. Like you actually gotta pay attention to what it
Yeah,
says.
it's not, I understand.
Maybe you're smart, Jack. All of us are like you.
I don't think any of you are stupid. Like, there's honestly more stupid people. Like, every day I bike past the train station, there's always at least one dude tweaking there.
Why don't you join me, bro?
No, one time I actually had a convo with one of the drunk dudes, and I didn't realize that the brown bag had alcohol in it. But he wasn't aggressive, so it's fine.
Why would just because they are drunk doesn't mean they're aggressive?
Yeah, but I'm saying it was like, I didn't mind it because he wasn't aggressive. Like, I don't mind talking to a drunk person. He was giving me bike advice, not that they were right, but do
Oh,
we,
wait, bro, Nico's done. Oh no.
okay, do we want to look at, I can, if you guys use
I'm
the
not gonna
raise
lie, I
hand,
gotta join him too.
if you use the raise hand, I
We're
can,
cooked.
okay, they left, cool. I think these are good questions, conceptually speaking. Student pushes a box across a rough horizontal surface. When they say rough surface, that's how they're telling you friction is not negligible, which of the following includes all the forces exerted on the box. Interatomic electric forces. Okay. That means friction, I guess. Friction is like, I guess between the electric, like, I don't know. So I'm assuming force of friction, we have normal. Normal force is friction comes from normal force. Student and the weight. Weight is another way of saying gravity, the force of gravity. Gravity itself, you can sometimes refer to the gravitational acceleration constant, 9.8066 meters per second squared. But weight is Fg, gravity, force of gravity. So probably, I believe that's 4. At the instance shown, a string's okay. There's negligible friction, which of the following free body diagrams indicates the direction of the forces. Okay, so Fg is always going to be downwards unless we break it up into components. Tension is in the direction of tension, and normal force is always perpendicular to the surface. So that would be that. Two blocks AB are attached together with a string and pulled up an incline. But if anyone has a question, they can use the feature, you know. Up an incline by another string attached to block B as shown. Has a tension Ft, and the other string attached to Fp where negligible friction. Okay, which following correctly labels. Okay. Free body diagram of, okay. So this F1 on B, it's going to partially be, well, I think this is gravity. The vertical is just gravity. They didn't separate it into parallel and perpendicular. Although that could be like a trick. They didn't, since it's straight down. That's normal force up, so that's the tension to the right is Ft there. F1 is going to be equal to Fp, and it's going to, yes, F1 equals Fp because the string, okay. Let me see, block B is that doesn't make any sense. Block B is not pulling the string down. They're being pulled up, so I believe it's this. Also, block B is also pulling A up, yeah. Oh, I misread this. The string between the blocks has a tension Ft. I'm sorry, so that's... because the string between the blocks is pulling B down the incline. I mean, technically, that wording is really confusing. I don't know which one it is. Block A is being pulled up the... I guess it's technically not being pulled down. It's being pulled in the downward direction, but I don't know if I would say it's being pulled down because it's going upwards. So I'm not sure for that one. Atwood machine. I don't think we really covered this, but 2 blocks attached. MA, MB. MA is less than MB. So, okay. There's a free body diagram for each block. So this, if we were to flatten this out, like MB is going to have a greater force of gravity because it has more mass times gravity. So this is going to pull downwards more than the string is pulling it upwards. So that means this one's going to go downwards. Okay. What's that? It's a correct statement regarding the accuracy. Okay, one thing to note, the force of tension between these two is actually going to cancel out. So like the force of tension, if we just look at the block MB system, the force of tension here is less than the force of gravity. And then for this, the force of tension is greater than the force of gravity. But if we look at the system that includes blocks MA and MB, this is FT, this is FT, they cancel out. So that means this length must be the same as, I'm sorry, this length must be the same as this length. Yeah. The tensions must be the same length. So, which is kind of interesting. Okay, it's the diagram. I believe they're accurate. Looks accurate. This is supposed to have a greater magnitude on top. This is a greater on the bottom. Yeah. And these have the same magnitude, so they cancel out. So you're really like only looking at, you could pretend you're only looking at the bottom half of the arrows. And this would also tell you enough about the system. not each individual block, but the system of both blocks. So that makes sense. Greater pull on B than A. Because the force of the string is less than the force of gravity. Oh, no, that's not correct. Okay. It's not less than the force of gravity for this one. It's more. Because the string is pulling up with the same force in both blocks. And yep, okay. That's right. Box slides up a short incline ramp, continues to travel. Okay, friction errors is negligible. Box slides up a short incline. Continues. I guess that's implying, okay. So it's always going to have a normal force, which is perpendicular to the surface at 1. And it needs to be pushed up this way. But gravity actually has a component that's going parallel. So we need a force to cancel out the parallel component. So it can travel up at, let's say, a constant speed or accelerate. So that means we need another parallel component in the opposite direction to keep it going this way. I guess theoretically. Yeah. I mean, technically it could still come off. But I would assume it's this one because gravity has a component in the parallel direction relative to the surface. So then you need another force to cancel it out. But then this is not correct, so maybe not. I don't believe. Okay. Okay, maybe it's actually decelerating as it goes up the ramp. That's also possible. So that just means it has gravity on it and then normal force keeping it. So it is technically decelerating in like towards the, or it's accelerating towards the like left and down, but it just has enough velocity that it will make it off the ramp. So I guess that's all we can infer. So it has the normal force, which is perpendicular to the surface, and gravity is straight down. Then here, the only force acting on it is gravity, which is straight down, same magnitude. Pushes block A and B up at a constant velocity. Okay. Force of friction is negligible. Okay. So the force of, okay, they're both gonna have two identical blocks, same mass. So they're both gonna have the same normal force, right? Okay. I know immediately it's gonna be this one. And the reason being, this little arrow, these two arrows have to be the same magnitude, this right one and this left one, because they're the interface of the blocks pushing on each other. So that arrow is block B pushing on A, that's block A pushing on B. They both have the same gravitational force going downward, straight downwards, because they have the same mass, they're identical. Normal force is the same because Fn is equal to mg, what is it called? Oh, sorry, I'm blanking. Mg cos theta, I believe. Yeah, mg cos theta, or mg perpendicular. Yeah, mg perpendicular. So they're gonna have the same normal force, and this is the force of the car pushing on the block A. So I believe that's correct. Hopefully it's correct. We'll find out. Hello, whoever joined, Gion? I don't know. A large block of mass M is at rest on top of a platform. Oh, this is great. Okay, these two objects are suspended. Okay, sure. Okay, the number of upward forces acting on the box platform system. Upward forces. So there's tension. And then there's the force of normal on it from M to M, which is, so, number of upward forces. Let's see if this is, so technically this is pulling it upwards. One here. This is pulling it upwards. Little m is exerting normal force upwards on big M. And then technically, even though it's not moving, there's this tension here. Prevents it from going down. So those tensions are equal. We have 4 equal tensions. Let's see. Okay, I guess on the system, that's, don't think 4 is the logical answer. I feel like it would either be 5 or 2. Oh, big M is greater than little m. I did not notice that. That's my fault. Okay. So it's pulling downwards. There's 2 pulling upwards, and the normal force. I think it's that. Because if we're ignoring the normal, which makes, because they cancel. But technically, so this is pulling down, but at the same time, the tension does pull it up. I guess it would have to, because they have to cancel out, so there has to be a tension there that's upwards, the opposite direction. Then this tension keeps that block from dropping. So I'm assuming it's 4. This is not a good reason. The 2 pulleys is not a good reason. 2 different blocks, AB, are next to each other on an inclined smooth surface, which has negligible friction. An applied force FP pushes block A as shown. Student sketches a free body diagram, which of the following statements best describes the change, if any. Okay, FG is drawn to the ground. FP is correct. There should be adding in FB. This means FB on A, so the box B pushing on A, pointing down the incline. I guess I don't know that it gives the answer immediately. Is that what we just did? No, it wasn't. Okay, well, we can't check it. I don't know how long that takes. Anyone have any questions they wanted to? Okay. No one have any practice questions? You can like click the raise hand button. Then you can talk, or just send it in the chat. Oh man, that's horrible. Alright, let's see. I don't know why I got this. Weight of the box. Yeah, I don't really know what interatomic electric forces is referring to. I don't like. It's my bad. Attraction. Okay, so I guess gravity does not count because it's. I don't even know what type of force it is. It's just simply not interatomic. So that's why we don't really use that term. I don't think. This is a bad score. Oh, so it was pulling down. Okay. Yeah, I wasn't sure. So technically, it's pulling block B down the incline, even though block B is going up. It's saying it has negative force is causing a decrease in acceleration. So that's what they mean by pulling down. I think that's very ambiguous wording. So those 2 I understand why I got them wrong. Okay. Which system? Oh. Yeah. So that's like I don't think College Board would ask something like that. The issue was like it didn't specify which system it was drawing a free body diagram of. So like if we had a system that was just AB as a single object, we could pretend like AB was one block and there was just an FP exerted on it, then this would be perfectly valid. So that's kind of, yeah, it's a wording thing that I don't think that's much physics. I don't think Mr. Huang would give a question like that. Oh boy, what is this? Where did the dx go? Well, you integrated, so the dx disappears, right? The dx just means integrate this with respect to the variable x, so it yeah, disappears. Yeah, I got those wrong, but frankly, they weren't, like, not for the reason I expected. One ambiguous. Two, I don't know what interatomic electric forces are, but apparently gravity is not one of them. It just means like collision forces, like contact forces. Thank you, Vincent. Anyone have like questions they want to do? How do I super chat? You probably have to pay for it. I'm not sure what that is. Yeah, don't donate, please. I don't have a credit card linked. It's not going anywhere. Is there any? Let me look it up. These are just. Let's see if this is a. Oh, it's a video. Practice. Oh, this is physics 1. Yeah, I don't believe any of this is relevant in chemistry. Maybe physics C. Here. Uh, yeah, I don't think this is relevant to us. These are like momentum center mass questions, which is possible to have, but unlikely. I'm gonna go over the notes, just read them through. Interesting. Okay. If I actually did any of the work, right? Macro versus micro, mass over volume, M over ABT. M just represents dm integrated. So it's saying like density of like a strip can be represented as a tiny bit of change in mass times the area of the surface times the tiny little like distance in a different dimension. Okay. So we know dm equals rho bt. Yeah, dx. Okay, x using the formula. We can pull out the 1 over m, which we have here is abt. 1 over abt. Or, okay, x dm is rho bt dx. I don't know what to say about this, x squared over 2. Rho bt over m. Yeah, rearranging this, rho bt over m equals a. 1 over a. I don't know. Not much to do with this. Is there anything anyone wants to go over? You guys like just gonna lurk? Yeah. Yo, anyone have anything? Can you go over pulley? Yeah. Do you have a specific one, or like if you have one? Is there actually, there might be on AP Classroom, right? What would that be under? Could be under this. No. Newton's third law. That wouldn't make sense for it to be Newton's third law. Do you have a pulley question? Because, this is a pulley question of sorts. I can do this. A block on a horizontal rough surface. Probably under the classwork. Was that on the, in the notes? Was that in the notes? I don't know. Let me look. Probably would be in the notes. We do have like some pulley stuff, but like I don't know what. It's kind of like a nothing complicated. I can go through them. We have like 2 basic pulley questions that we can solve for. I can like I can do this if you like. We have this and this. You have like a preference of these 2. Like this is what we did in class basically. Eric, do you have a the triangle? Okay, sure. What do you want us to solve for? Well, we can really solve for anything. I think we're solving for acceleration of the system. Okay. And we're gonna assume, I think we can find really anything. We're gonna find A first. Okay, that's easy to find. A. And big M is greater than little m, and these are masses. Okay, so I like to flatten the system, so what this would look like, M, then we have this, there's a pulley somewhere, that's the pulley, right? Then we have little m, okay? And this has the force of gravity, right? Fg1, and this is gonna have Fg well, assuming friction is negligible. I don't think we learned did we learn friction? I don't think we did, right? We didn't learn that yet, to my knowledge. Let me check, just to make sure. I don't want to be misleading. I don't believe we did. Friction. Okay, well, we didn't really go over equations for friction. So I'm gonna pretend friction is negligible, alright? So friction's gonna be negligible. Zero newtons, if that's not clear. Okay, so this is our system. And here we're gonna have, if we were to, oh crap, sorry. What we do is we kind of rotate the axes, right? So, however we want to look at that, I don't want to do it like that. Like this way. So, if we look, we have FG here, okay? FG2. But we can kind of split it this way. So this is FG, we'll do it perpendicular. Then here we have FG parallel. And FG perpendicular is going to be equal to FG2 is what we called it, times the cosine, because that's adjacent, cosine of theta, which is that angle. Okay, and then FG parallel is FG2 sine theta, right? So since friction is negligible, we don't need to worry about FG2 cos theta, because friction relies off of gravity perpendicular, but we don't need to worry about gravity. So we have FG parallel is one of the forces acting on it. So this is FG parallel. I don't know why that's that color. I think it's tripping. Yeah, I accidentally switched it. So FG parallel. So that's one of our forces. So now we can draw that into here. FG parallel. Okay. So this is our system flattened, like as if it were put into one dimension. Okay. So our Fnet equals ma, because that's Newton's second law. Fnet equals ma. We want to find a. M is the generic. We'll just say mass for now, just so it doesn't have variable overlap. A. Okay. Mass A, and it's also equal to, since FG1 is bigger than that, it's actually going to be FG1 minus FG parallel. So, and that's going to be equal to, FG1 is equal to big M times G. And FG parallel is little m times G times the sine of theta. Sine, because this is the opposite of the triangle. This is the hypotenuse. FG2 is the hypotenuse. So hypotenuse times sine is going to give us the opposite. So mg sine theta. And that's going to be equal to mass times A. Okay. Now, this is going to give us A equals mg minus little mg sine theta over the total mass of this system. So that's what we're dividing by, which is big M plus little m. That's clear. So you can factor out the g if you want. You don't have to. That's our acceleration. Force of tension, if we wanted to find tension, I'd rather not, but one way of doing it is this mass is going to have this acceleration. So you could multiply this, right, by that mass. Okay, and that's going to be our F net for this block. You would say all of this, right, is equal to Fg minus Ft. And you plug in big Mg there, and you could solve for Ft if you want to find force of tension. And both blocks would have the same force of tension because of Newton's third law. Yeah, that's all I have. I think I'm gonna. Do you have any other questions? I'm gonna wrap. I'm gonna go to sleep. All right. Well, I'm gonna end the stream. And screen share because I'm tired. Yeah. See you later.